We are on to our final section of this unit, and it is on equations dealing with fractions. And unlike everything else we've done, which has involved expressions, when we have an equations, we have an equal sign. And when we have an equal sign, we are going to, by the end, be able to get something like k equals some number, like 3 or 2/7 or something like that. So we, unlike the other ones where we just try to make the fraction into a single fraction as fully reduced as possible, we are now trying to get an answer. And because there's an equal sign, we don't only have the top and bottom of a fraction that we can multiply the same thing by, we have a left and right of the equal sign. We have two sides of the equal sign we can do stuff to. And that opens up a lot of doors as well. Now, if you check out the flowchart, you'll notice that everything is very connected together, except over here in the corner, we've got equations has no friends here. So let's look at this and see if we can follow this pathway here. For equations, it says follow the adding rules for each fraction. So it does say actually we need to kind of go over here a little bit. And by follow the adding rules, what we're really saying is let's get ourselves common denominators and combine like terms on the same side of the equal sign. So then we will proceed to these other steps. So we're going to treat it kind of like an addition problem in that we want to have common denominators. And when I look at a problem like this, I look on the left side of the equal sign and I see 3 on the bottom, I see a 10 on the denominator of the other one. So since they don't have anything in common, 30 is the smallest thing I can get to. I'm just going to multiply this side over here by 3, top and bottom. Of course, making sure I wrap everything in parentheses right away just so I don't make any mistakes. I'm going to multiply this side over here by 10, top and bottom, so that both denominators will equal 30. They're both 10 times 3. You'll notice on the top, I will need to eventually do some distribution. So let's go ahead and do that right away. So now that I have common denominators, I distribute on top, leaving me with 10 times k is 10k, and 10 times negative 8 is negative 80. On the other side, I have 3 times k is just 3k, single term. And all of this is over my common denominator of 10 times 3. So if I were to rewrite this, you don't need to do this, but if I were to rewrite this just to make this a little clearer, I have 10k minus 80 over 10 times 3 equals 3k over 10 times 3. Now don't try to start reducing this right away because that would defeat the point. That would go backwards from what we just did. We intentionally unreduced it to get common denominators. Watch what I'm going to do. I'm going to take the entire left side and the entire right side and put some parentheses around it. I'm going to multiply the top. Whenever I multiply both sides, I'm always multiplying by the top. Multiply it by 3 times 10. Multiply it by 3 times 10. And when I do that, because I multiplied both the left and the right side of the equal sign by the same thing, I am doing something equivalent. We're used to doing that when we solve equations all the time, but when we see fractions, we typically are so used to what we did over here, this whole multiply the top and bottom thing, that we forget that when there's an equal sign, we can multiply on both sides of the equal sign. So watch what I have. That 3 is going to factor out with that 3 down there. This 3 is going to factor out with this 3 up here. This 10 is going to factor out with that 10 down here, and this 10 with this 10 over here. Meaning that those things on the outside essentially disappeared. We are left with only the numerators. I can rewrite this problem as 10k minus 80 equals 3k. And all of a sudden, this is feeling like something that you probably are pretty confident with. So let's hide all those fractions. We don't want to look at that. And let's solve away. Well, whenever we have only k or x to a single power, no x squareds or anything like that, it's usually easiest to get all the k's on one side and all the numbers on the other. We could choose to, since we have a k over here, get all the k's on this side, so we could subtract 10k, add a negative 10k to both sides. And if we did that, this positive 10k and this negative 10k would add to 0. We would be left with negative 80 on the left. On the right, we would have 3 minus 10. Since they're both k's, like terms, we would just take 3 minus 10 as negative 7, times it by k. And then to finish out the problem, we want to get k alone. This is multiplication, so we need to undo multiplication with division. Our goal is to get k alone, so we get rid of everything that is not k by dividing both sides by that negative 7. And we get 80 over negative 7, which if we make both of those positive, the negatives can undo each other. 80 over 7 equals k. And since 80 is not divisible by 7 and 7 is prime, we are done. So let's zoom out a little bit. As we look at this problem, one thing to check for is that there's no place where this number, 80 over 7, would plug into the denominator and cause it to equal 0. Since we don't even have a x, or in this case a k, in the denominator, we don't need to worry about that in this problem. But just something to be aware of. One thing that it does ask you to do on each problem is to show that you have checked your answer in the original problem. And that is something that we'll be looking for on all of the assessments, including the quizzes. So make sure that you are plugging your answer back into the original problem to see that it works. And so here's how we're going to check this. We're going to take the original problem, k minus 8 over 3 on the left side, and we're going to replace k with 87ths. 87ths minus 8 over 3 equals 87ths over 10. That's what we have. And so we're now going to plug that into a calculator. Let's use my favorite calculator in the world here, the Google calculator. If you just type a math problem into Google, it will give you a calculator. Who knew? What we are going to do is we're going to take parentheses and take that, see if I can bring that problem here into view, 87ths, 80 divided by 7, minus 8, and then close the parentheses. That's our numerator over here. And we're going to divide that all by 3, because it's all over 3. And hit equals, and we get 1.42, something in that neighborhood. So like 1.42-ish. And then let's try the other side. On the other side we have on top 87ths, and then we're going to divide all of that by 10. That's what's going on down here. And we get 1.42, something like that. The thing that we're looking for is not the answer, but the fact that the answer is the same on both sides. And in fact, it is very clear that these two are the same. And so that means that we checked it. Right here, this is our check. So that shows that we have checked it. That is something you will need to do on each one. The nice thing about that is it tells you if you got the answer right. If you did the problem correctly, that check will always work. And if you didn't do the problem correctly, then it will not work. The other thing that checking does is if for some reason you get a solution that causes the denominator to have a 0 in it, you'll detect that and you'll be able to say, hey, I got a solution, but it didn't work. When that happens, it's called an extraneous solution. It happens once in a while, not that often, but just something to watch out for. The checking step will allow you not only to check for answers in a normal case, but also look out for that weird situation that could happen. Let's try this example, number 43 here. We need to always start by getting a common denominator. And the reason we get common denominators is then we can essentially make our denominators go away using the multiplication of both sides like we did above. This middle fraction has 6 times r. The other ones just have either a 6 or an r. So we're going to make sure that we can get all of them to have a 6 and an r. Start with putting everything in parentheses. Since I see subtraction in here, I am going to change this to addition and multiply this here by -1. Subtraction scares me and causes me to make mistakes all the time, so it's best to just get rid of it. And that would be true of all of math if it were up to me. So, enough with my ranting on subtraction. Times both the top and bottom of this by r to get 6r. Middle one already has 6r. The far right one needs a 6, and a 6 times -1 times that. So now we have 3 things multiplied over there. That's okay. And now everything is a common denominator. In our addition steps, we always want to make sure that we are getting the numerators completely distributed. So let's do that. 1 times r is just r. 1, well, that's just 1. Cross that out. That doesn't change. 6 times -1 is -6. We'll just write that as -6. We do that one first when we're doing multiplication, when we have 3 things multiplied. Do the 2 easiest ones first. And then let's take that -6 and distribute it out to both of these, giving us -6r. And -6 times 6 is -36. So those go away. And over here, we have an addition problem. So I'm just going to focus on just this side for the moment. After doing some of that cleanup, we are left with, on that side, an addition problem, which means that we can, and we have common denominators, so we can rewrite that side of the equation all over a single 6r. We have a 1 here. That's that one right there. We have a plus sign right there. And then we have up here -6r, and then plus a -36 or -36. All of that over 6r on that side. On the other side of the equal sign over here, you will see that we have r over 6r. Much simpler over there. Finally, we have one fraction on each side all combined together. And so now, even though I didn't clean up my like terms, you could do that now if you wanted, but I am going to put some big parentheses around both of these fractions and multiply by what the common denominator is, 6 times r, 6 times r on both sides. When I do that, the 6's undo each other, the r's undo each other down to 1. Same thing on this side, meaning that we no longer have fractions. Woo! Alright, let's rewrite this. R equals 1 plus -6r plus -36. I can start by combining like terms on the same side. That's always a good place to start when you're doing stuff like this. 1 and -36 make -35. So now I have all that on one side. Since I have only r's on the left side and I have r's and numbers on the right side, I'm going to choose as my most efficient way to get this all on one side to take this chunk and ship it over the other side. When you ship it over, what I mean by that is we are going to add 6r to both sides. So if we were to just take that little spaceship and send it over, it would change signs to a positive. Or if that seems like voodoo magic to you, just add 6r, because that's really what we're doing. So we have 1r, remember r and 1r are the same thing, so 1r plus 6r is 7r, equals positive 6 and -6 go to 0, and on the other side we have -35. Finally, 7r is 7 times r, and we want r alone, so we need to get 7 out by undoing it. We undo multiplication with division, and if we do it to one side, we do it to the entire other side, meaning that 35 divided by 7 is 5, and that negative sign that you almost forgot about it, I know you almost forgot about it, don't lie and say you didn't, is going to come along for the ride. So -5. Over here we have just r after the 7's cancel each other out to 1. So r equals -5. That smells like an answer if I've ever seen one. So r equals -5. And now, good luck trying to figure out what the original problem was after all that writing. But we are going to plug it back in to make sure that we did it right. So let's go ahead and choose a new color here. And we're going to plug that back in. Now, you may not have this special power that I have right here to pick up your work and just kind of shrink it in the corner. But look at that. -5 is going to get plugged into this problem everywhere we see an r. So we see an r here, here, and here. So I'm going to write 1/6 equals 1 over 6 times -5 minus -5 plus 6 over -5. Now, -6 times, or 6 times -5 right here is going to equal -30. I'm going to try to write it in one place like that to keep it nice and clean. -30. -5 plus 6. -5 plus 6 is going to be +1. And so on the left side I have 1/6. On the right side of the equal sign I have 1 over -30 minus 1 over -5. I don't like subtraction. You could do it in your calculator straight like this. I would personally make that plus a negative up here. If there were more things up here, I'd always put parentheses. And since I have a -1 over a -5, I could make it a +1 over a +5. So I have -1/30 plus 1/5. Let's go over to trusty Google. Clear this out. -1/30 plus 1/5 equals 0.16666. And over on the other side we have 1/6. 1 divided by 6. So over here 1/6, again 0.166. They are the same. Woo, we did it right. Okay, so now we have gone through a couple examples here where everything works out. The most complicated ones that you're going to see is something like number 46. I'm only going to show you the first step just so that you feel confident getting started in something like this if you come across it. The denominator is 5a minus 1 in this problem. This term right here needs to become a fraction to be able to get everything with common denominators, meaning that you're going to multiply the top and bottom of this. Remember, the bottom is really a 1 right now. So you're going to multiply the top and bottom of this by the entire 5a minus 1. 5a minus 1. Such that you now will have 1 over 5a minus 1 plus 5a minus 1 over 5a minus 1 equals 2 over 5a minus 1. They all are over 5a minus 1. You'll be able to combine your fractions over on this side of the equal sign into a single fraction. You'll be able to then multiply both sides by the common denominator so that there's no more fractions. And you'll be left with something that looks like 1 plus 5a minus 1 equals 2. So all of that scary math was going to come down to something that looks like this. You'll be able to add your +1 and your -1. A will be, and that goes to 0. 5 times a, you want a alone, so you divide both sides by 5. And after all that, you're going to end up with something fairly straightforward like this. I encourage you to go through the steps on your own a little bit to play with this kind of problem and get more comfortable with this. If you're getting an endpoint like this, you are on the right track. Checking this problem isn't going to be too bad either, because you're going to plug that into the a's right here, and 2/5 of 5 is just going to be 2. And 2 minus 1 is just going to be 1. So you're really going to say this problem is going to come down to 1 plus 1 equals 2. So if you think you can handle that, you can handle anything. Good luck. Go kick some butt.